Yeah, hello everyone, welcome. Can you hear me? Hello. Okay, thank you. Just we're waiting some time, then we'll start.
Yeah, that guy.
Okay, so let's go. We will start today's session. So hope all are well. And I hope you already get the previous material, mainly previous decorative video class, and also get the previous practice code and others material. Okay. And today is our fifth number test. Okay, so basically today discuss about the some advanced topic on Google Earth Engine, mainly how to work with air quality monitoring. Okay, using the combine of Google Earth Engine, also combine with the ArcGIS Pro. So basically, live training. Then we talk about the problem solving class also. Okay, so let me share my screen. Just a minute. Okay, can you see my screen? Is it visible? Can you see my screen?
Yes, we can see it.
Okay, thank you. So let's start. Okay. Okay, so let me share my another screen. I think today discuss about ArcGIS Pro. So let me share my another screen. Just a minute. Okay, can you see my screen? Yeah. Okay, so today we discuss about that how to work with ArcGIS Pro, mainly how to load the data, how to create the map. So all of things we try to explore using the ArcGIS Pro software. So here I already opened the ArcGIS Pro. Okay, so this is software. So now I simply click on the map, and further I just create a new project. So you can see it show the project name. So the default show the my project 4. So I want to save the project in a specific folder. Just I click on here, and then I simply save my project in a specific folder. Again, mainly your Google, your drive, okay, C drive, D drive, or any drive. You can easily store it in your project. So in this case, I simply save my project in the suppose in the G drive. Okay, and further I simply put my project name. You can put any name as a project. So it's this project mainly for ArcGIS Pro project, not Google Earth Engine project. Okay, so it's a different project mainly it's just only for ArcGIS Pro. ArcGIS Pro file we simply save in this name. So I put the project name, suppose air quality. So just I put the name air quality. You can put any name as a project, and then okay. So now this project is creating, and open a new file. Open a new file of ArcGIS Pro. So let's opening the ArcGIS Pro. You can see this also saving the project. So if you check it at the top right left side, you can see it show the air quality. So basically this is my project folder. Okay, this is my project folder. So in this folder, when I go, I can get all of file. Okay, suppose if I show you that in my folder where I save it. So I save it in my folder in the local disk, mainly G drive. So this G drive, and I put the name is the air quality. So this is my folder. This is my project folder which I created. Okay, so now here I can get all of file, all of data, all of things I can easily access from this folder. So it's called the project. Okay, so this is the project of ArcGIS Pro which I created. So further, when I import any file or export any file, then I can easily get under the folder, air quality folder. When I just open, then I can easily get all of important file or important documents. It can be time series chart, it can be geotiff file, everything will be stored under the air quality folder. Because in my ArcGIS Pro, I put the project name is the air quality. So now it is stored all of those in the air quality folder. So this is the user interface of ArcGIS Pro software. So now I want to connect the Google Earth Engine server. Okay, so I need to connect the Google Earth Engine server. So for that, previous class I already discussed about that how to install the GEMAP package in the ArcGIS Pro environment. So just I simply click on the analysis, and now if you check, it show the some tab. So one tab, if you check, it show the Python. It show the Python. Uh, just I click on here, and Python notebook. I create the Python notebook. Just click on here. So now it open the another window, and in this window you can see it show the initializing the kernel, and now it's opening the new code editor. So in this code editor, we can simply write our code or analyze our data. All of things we can easily do in here. It's working. Just some time need for opening the new notebook. Okay, done. So now I can get it's opening this type of new notebook. And if you check the new, this notebook is also stored in our project folder. If you check the project folder, our quality, we can get, you can see this is a new notebook. Okay, basically this file, this new notebook file also stored in our project folder. Okay, so further, when I need this file again, then I can easily open. Okay, and then also work. So now this project file, I simply import some library. So one library we already know about that, GEMAP. So just I import the GEMAP library. So import GEMAP library. Also import Earth Engine library. So this is the common two library we need when you work. So I already show you that how to install the GEMAP. So just I simply run. So you can see now it's working. So it show this type of symbol. It means that it's now working. It's mainly load. So if there is no problem for installation, then it will be work and we can get the successful result. So it's now loading. If you check, it's working. Mainly importing the package of GEMAP and also Earth Engine. done, successfully done. There is no problem. You can check it, show the successfully done. Okay, this it successfully exported or execute the code. There is no problem. So now further is simply apply the authentication. So just put here art engine dot authenticate. So here I already complete my authenticate. So now if you check it working, first time we simply connect with our Gmail for the first time. Okay, so simply click on the allow and then simply click then simply allow and then continue, then it will be okay. So it just need only for the one time. So previous time I already completed my authentication, so that's why it show that true, because I already complete this part. There is no problem. Okay, then I take the new cell and then initialize my project. So this project mainly Google Earth Engine project. Okay, if you simply check the code editor, so let me show you the code editor. Or code editor, we already have show you that how to create the cloud project or how to make the cloud project on Google Earth Engine. We already know about that. So this cloud project we can easily find out from the code editor. So in this code editor, if you check the top right side, we can get this is the project. This is my project. Okay, so this is my project name, EE Mizan 690. So this project I want, this is my cloud project. So now I need to mention this cloud project in my code editor. So let's go try to mention it. So just simply apply here again, art engine dot initialize size, then put your project. So put project equal, just put your cloud project name. So for my case, this project name is, further if I run the code, so now it's also loading, just take some time, and then it also I hope successfully initialize with my cloud project. And now it's connect the Google Earth Engine with ArcGIS Pro. So now it's successfully done. So just we simply run the 3 line of code, and then we simply connecting the Google Earth Engine server with our ArcGIS Pro. Okay, so now I can easily load any data set. Any data set I can easily load from the Google Earth Engine data catalog. Any data set I can easily load, any satellite imagery, everything I can easily load. But in this case, today's session I discuss about that mainly air quality monitoring. So just I talk about only for the air quality parameters. But if you want, you can easily add any data set. It can be Landsat, it can be Sentinel, it can be Modis, everything. Every data set we can easily connect, and we can load the data, as well as we can also add the map view. So in this case, I show you the example for the air quality monitoring or air quality parameters, but you can also apply this type of things, any dataset you also apply later. Okay, so now how I can monitor the air quality monitoring using Google Earth Engine, we discuss about that. So basically in air quality monitoring, when you work with the remote sensing technique, we need some data. Okay, we need simply use some satellite data. So this type of data we can easily access from the Google Earth Engine data catalog. So one data set is very popular. We can easily use it. It's called the Sentinel 5P dataset. Okay, Sentinel 5P dataset. So this dataset we can easily access all of air quality pollutants. We can easily access. If you check it, just click on here and click the browse data catalog and click on the Sentinel. Mainly it's called the Sentinel 5P Cropomy dataset. And if you check the just click on the Sentinel option, it's opening. Okay, now if you check the Sentinel 5P, this dataset is very popular. We use the different types of air pollutants it is tracked, suppose ozone, then methane, formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide. So this type of gases we can easily access from this Sentinel 5P. Okay, and this data set is globally available. So this is one kind of sensor we also use to monitor the air quality. Not only for that, we also use the another one. It's called the MODIS AOD, mainly aerosol optical depth. We also use. So if I show you the data set, it's called the MODIS. I simply search suppose MODIS AOD. MODIS aerosol optical depth. It's also a very popular data set. It's also available on the Google Earth Engine. And we also get the data set from the NASA data, but we can also get it from Google Earth Engine data catalog easily, no problem. So this data set, MODIS AOD, aerosol optical depth. It also help you to monitor the air dust, as well as we can also use the data set to monitor the particulate matter, PM 2.5 or PM 10. We can also monitor using this data. So I also try to show you that how to use and then how to get the data for this type of any study. You can easily get it. There is no problem. Okay, and it's available. So how to use the MODIS AOD data and compute the PM 2.5 help of linear regression. We also discuss about that. Then you can easily get the more better idea. Okay. So now if you check this type of data, there's a lot of data, aerosol index, then cloud, then you can see the carbon monoxide, formaldehyde. So this type of data, how I can add in my ArcGIS Pro, okay, in this code editor. So before that, first of all, we need to import our study area, import our shapefile in my ArcGIS Pro. So how I can import the shapefile? So basically this shapefile is loaded from my asset tab. Okay, suppose here I already uploaded a lot of shapefile, you can see. So this type of shapefile I can easily load in my ArcGIS Pro software. So in this case, suppose I just simply open a shapefile in my code editor. Suppose this is the Dhaka city boundary shapefile. So this shapefile I want to load in the ArcGIS Pro. So how I can load? Just click on here and copy. Just copy from here. Just copy this feature collection. Just copy. Okay, and then go to your code editor again and take a variable name. You can put any name as a variable. I put the name, suppose ROI, and then paste. So now this is my boundary of interest, Dhaka city boundary. I already uploaded in this boundary in my asset tab. So how I can upload, I hope you already know about that. I already discussed about that, how to upload the shape file on the asset tab. Okay, so now I simply copy this function with my asset ID and further paste in my code editor. Okay, so now if I run the code, if you check, just I run the code, there is no problem. It means that this variable successfully stored this boundary. Okay, so now I want to import it, some my data set. I want to import it. Suppose I want to work with this data set. Suppose nitrogen dioxide. If you check, this is nitrogen dioxide. I want to work for that, and I want to make the nitrogen dioxide concentration map. So how I can make? So this is the image collection. So this image collection I need to import in my code editor. So just I copy, and then paste in my code editor. Just paste here. So now I just give a variable name. You can put any name as a variable. I put the name, suppose NO2 equal. So now I simply imported my image collection. So this image collection I need to filter. Okay, this image collection I need to filter for different condition. We already know about that, how to filter. Okay, so first of all, we need to select the band. If you check, this data set have different types of band. Basically, you can see this is the nitrogen column number density. Basically, this it's compute the density. Where is the high density? Where is the low density? And this unit is the mole per meter square. Okay, and this is the another band. It's called the tropospheric nitrogen column number density. Mainly tropospheric vertical column of nitrogen dioxide. Tropospheric vertical column of nitrogen dioxide. This is the stratospheric, basically stratospheric vertical column of nitrogen dioxide. So different phase we also get it. Suppose I want to work with this, just I copy nitrogen columnar density, just I copy the band, and then simply use a function in here. So I put the function name is mainly select. So put here the dot select and then paste this band. Okay, there is no problem. You simply paste the band in here. and I simply put my time period when I need the data. Okay, so for that, just put here the dot filter date function and put your time when you need the data. Suppose I need the data from 2019, suppose 1st January, from I need the data, suppose 2024, suppose December 31. Okay, I need this data for this time period. Okay, after that we also apply another function, mainly it's called the filter bounds function. So put here filter bounds with my study area, which is ROI. Okay, so in this case, if you check, we can use this type of things. Now if I run the code, it show a problem. It show the problem if you check unexpected indent. So in this case, for that, we simply use the bracket. Okay, when I write it, simply use the bracket, mainly first bracket, and also close the first bracket. Just I close in here. So now check again. So now there is no problem. Okay, so when you can see, just I simply write all of code and simply define the first bracket start and first bracket end. So now there is no problem. Okay, so now it is stored the NO2. So now if I check how much NO2, just I simply call NO2 how many images in this collection, and I apply suppose size function. So now let's check. When it's computing how many images, I find out that you can see total number of image collection in this NO2. How many images? We find out that total number of image collection in this uh, storage. It is stored total 30,888 images. So this is the collection, total number of image collection. Okay, so this is the way we simply import our image collection.
You need to zoom your screen. We are not seeing the clearly.
Okay, so in this time it's ArcGIS Pro. It's not possible to zoom. Okay, it's ArcGIS Pro software. So if I just okay, so just let me try. Okay, now it's okay. I got it. Yeah.
Okay.
Okay. So now this is the coordinate. Simply zoom. Yeah. So now it show you that you can get yeah. So this is the total number of image collection. How many images I have in my collection? I find out that. So now I load my data set. So this is the way. Okay. So not only for this data, any data set when you work, just apply the same procedure all time. Just apply the same procedure for any data set, not only for that. It can be Landsat image, it can be Sentinel image, it can be Modis NDVI, it can be whatever, everything. Just apply the same process. Okay, then we can get the total number of image collection. So this image collection we can easily visualize. Okay, as well as we can use it for make the time series chart. So previous class we discussed about the time series chart in this code editor. Okay, ready-made dataset, unready-made dataset. Further, we simply use a function UI dot chart dot image dot series function. Okay, so this type of function you already use and make the time series chart. Okay, I hope you also now learn about that how to make the time series chart using this function. This UI, this function is only work for this code editor. Okay, this function is only work for this code editor. But when I work with this type of code editor, suppose this code editor, then UI.chart.image.series, this function is not work. Okay, so this function is only work for this code editor, only for the JavaScript API code editor. But when I make the time series chart using this code editor, then this function is not work. Okay, so basically this is the UI function. UI function is only work for JavaScript API code editor. Okay, but now how I can make the time series chart using this collection, using the help of Python. So we already know about that. Python have a one opportunity. We can easily integrate different types of Python library. Okay, so previous classes I already discussed about that, how what's the benefit to use the Python, what the benefit to use the JavaScript. So this session I discussed about that, how we can easily connect different types of Python library with Google Earth Engine. Suppose I can easily connect pandas, I can easily connect geopandas, I can easily connect matplotlib, I can easily connect scikit-learn, I can easily connect different types of Python library. I can easily integrate help of Python. Okay, so this is a big opportunity to use the Python. Okay, so now suppose I want to make the time series chart. So for that, I just use some Python library. So one library, suppose I call this library, it's called the pandas library. So I simply import the pandas as a PD. I also import another library. I put the library name, it's called the matplotlib library. So matplotlib dot py plot, I put the name as a PLT. So just I simply call the pandas and also call the matplotlib.py plus PLT. So these two library, it's another Python library. So this type of library I can easily connect with the Google Earth Engine when I use the Python API. So not only for that, for the different types of analysis, we can add different types of Python library, and it also help you a lot of things, a lot of analysis we can easily do using the Python and integrate with the Google Earth Engine. So now I simply import and run the code. So these two library, we face one problem. This problem show that no module matplotlib. I put the wrong spelling, matplot. It's a lib, L-I-B, L-I-B. And now try again. Yeah. So it's also imported. There is no problem. As well as I also import the another library, suppose NumPy library. It also need further. So I also import suppose NumPy. So import NumPy as, I put the name suppose NumPy as NP. Okay. So these three libraries simply imported in my code editor again, because I also use after some time this type of library. So now this is my total large number of image collection I find out in here. And now I want to make suppose time series chart. After that, we also try to visualize the image, okay, mainly your map. So I simply imported my necessary library which I need to load the time series chart. So now we simply create the data set. Okay, we already have the data set, but this data set we need to apply a function. Okay, so basically we create a function. This function compute the average, concentration, compute the average concentration for every day. That was first day, second day, third day, every day. As well as if you want, you can also make the monthly or annually. So both of things I try to show you that how it will be work. Then it will be more helpful for you. Yeah. Suppose I want to monitor monthly and yearly. Okay, suppose yearly or monthly I want to compute. Suppose each year average. Suppose month of January, what's the average concentration? Month of February, what's the average concentration? All of month average concentration I want to compute. As well as I also want to compute suppose yearly, each year, suppose 2019, 2020, 21, 22, 23, and 24. Each year I want to compute. So now I create a function. It helped me to compute the data monthly average and also yearly average. So let's go to create a function. So when you make the function in Python, we need to apply the def, this keyword, and put the function variable name. I put the function variable name, suppose monthly mean. Okay, I create monthly mean, and then I put here suppose year. This is my one element. Another element I put suppose month. So now what I need using the year and month, what I need to define my argument in here. So you can see this is the function for Python, but when you work with the JavaScript, we'll use the another function, another structure. Okay, but now I simply define the def, put the function variable name, then put the element name, so year and month. So now this year and month, what I need, so how to use the year, how to use the month. So this thing I simply define in here, it's called the argument. What is my argument using year and month? I need to explain in here. So first of all, I simply define start and end date. So I take a variable, suppose start equal, I created date frame, so art engine dot date dot from year month day, and I define my first date. Suppose it will be start from year, then month and first date. So I define my, you can see the year, month and first date. Okay, so now this is my start, and also define the end. So end equal to same ee dot date dot from year month day. So now in this case we can also represent the another way. Suppose from the start I take the advance one month, so for that simply call the start. So from the start I take the advance one month, was advance one month. So this is my end. Suppose I create the monthly, suppose when start date, suppose 1st January, then in date it will be in advance 1 month, suppose it complete the full 1 month, or take the February, then March, then April, then May, so every year. So when I put the advance 2 month, then it take the advance 2 month. When I put the advance 3 month, then it take the advance 3 month. So now I put the from the start, it just take advance 1 month. Okay, so now I just call the another variable name. Suppose I put the variable name is img, and call my image collection. I already have, you can see the 30,888 image collection, and it is stored in this variable. Just I copy the name of this variable, just I copy and paste here, and I define, just put here the filter date, and put here start date and end date. Yeah, we'll be able to define the started and end date. So now every month I compute average. So put here the dot mean. Suppose you need the maximum, then put here the max. You need the minimum, put here the mean. So I need the average concentration, I put here the mean. Suppose any other data set, not only for that, suppose you need to compute maximum NDVI, so then apply just here the max. You need suppose minimum NDVI, put here the mean, or maximum temperature, what you need, same process all time. Okay, so just I put here the mean, it's the average, I compute the average, each month average. Suppose January, February, March up to December, all of month average I compute. Not only for that, I also extract the values. Suppose each month I want to extract the values. Suppose for January, what's the value? February, what's the value? March, what's the value? April, what's the value? May, what's the value? Average value I want to compute. Statistical value I want to compute. So for that, I take the another variable, suppose val, and call the image, and apply the reduce region function. We already know about that reduce region function. A lot of time we already use the function. It mainly help you to compute the statistical value for a specific boundary. Okay, so I simply apply the reduce region function, and I put all of argument one by one. So first argument, it called the reducer. I put the reducer art engine dot reducer dot mean function, we simply apply. Then geometry, geometry, it's your shapefile variable name, which is ROI. Okay. Then put here the scale. Scale is the resolution of your satellite imagery. So if you check the scale, what the scale, what the resolution, if you check this resolution in the 1113.2 meters, just use it 1113.2 meters. Then put here we also use the max pixel. Okay, it also help you because when you work with the big study area, it creates some problem. We need to apply the max pixels value. It's a 1E13 and not use the colon, because for the Python you simply use the equal sign, not use the colon. Okay, colon is need only for the JavaScript when I write the code, but in this case you simply apply here the equal sign. So I simply define all of those one by one. So now it computes, suppose is year, is month, it compute the average value and also compute the statistical value. Okay, it just simply use the reduction function, it's compute the statistical value. So now what I return from this function, I need to define. So what I return, so I want to return from this function as a feature, ee.feature, but in this feature there is no geometry. We simply apply the none, meaning there is no geometry, but we have only value. We have two types of value. One value is for date, it's basically month and year and month. So I simply define, make a dictionary and define here, first is date. This date, it just come from start, basically from here. And we also define the format. So let's define the format. So this format, it just show only for the year and month. So just put here year format, basically year. Okay, total 4, and put here the month. So this format, so it display only for the month and year. Okay, suppose 2021 January, 2021 February, 2021 March, 2021 April. So all of month, it just show only for the year and show only for the month. Okay, because we compute the every month average value, so I think it also better for that, no problem. Okay, so then we also get the another one, it's called that NO2. So it's come from mainly statistical value. So this value, it's come from this variable, just I copy. And then paste here. And before that, if you check, if I show you that another information, just I click and I show you that suppose NO2, this collection, I want to show you that, just I run. So it showed the one problem. This problem is that there are a lot of data sets, so that's why it's not showing in here. So I just consider only for the first item. Yeah, I just show only for the first. So just show the first, only for the first data. And if you check the data format, this is the bands and this is the band name. Okay, just click on here. Here I find out that this is the band name. Basically, from this band, we can get the value. Okay, and if you check the properties, so it shows all of properties about this image, all of information about this image we also get from here. So I just copy the band, copy this band name. It's neat because I get the statistical value from this band. Okay, so I need to mention in here. So this NO2, this it's get from this band. Just I put the band name. Okay. So we return from here, look like that. So this is the function we simply create. So now after creating this function, we create the feature. Okay. So in this feature basically, first of all, we just take a variable, suppose features. And in this feature, we put the blank features. We not put any kinds of information in these features in this list. We add later after some time. So I create the variable feature and I put the empty. Okay. Because I want to add the later data after some time. So I create the empty features. And then I simply put here for function for y in range. I create a range. Suppose it will be start from 2019 to suppose 2025. Okay, I create that one. This is the range of year, as well as I create another range. Suppose for m for month, I put m in range. Okay, so I put the month range, suppose January to December. After that, I put my features. So I call the features. I call this empty features. So now it will be stored in here. Just I call empty features and apply the append function. So append with monthly mean. So I already defined the function monthly mean and paste here monthly mean. And monthly mean we define here year and month. Okay. So now simply call, this is the function variable name. So this function, how I again explain this code, then you can get the better idea. So first of all, we simply create a function. Okay, I put the element name year and month, and I just compute, suppose average is year, mainly is month average. So I start date, put the year, month, and first date, and I just take the from the start, I take the advance 1 month, and I just compute. So I call my data set. I have total this number of data set. I simply call, and after that I simply define the start and int. I compute the mean. Not only for that, I also create another code. This code basically compute the average for every image, for every month. Okay, it calculate the average, and you can simply date and nitrogen dioxide. So date, basically we can get the format year and month. I put this date format I need, and nitrogen dioxide, it's just come from our band. Okay, simply put the band name. We can get it from the band. After that, I simply define a variable. Suppose I put the variable name is that fc monthly equal, I define the feature collection. So ee dot feature collection and define the features. So I just call this features, paste here. So now run the code and check what happened. It's any problem or not. Oh my god, it face a problem. It show the problem invalid syntax, got forget a comma sign. We put the comma sign. So now let's check again. Fine. It show the start dot format. Perhaps you got a comma sign. Okay, I need to put the comma sign. Okay, so now there is no problem. So now let's check my final collection, mainly monthly collection. I try to check it. Or each month average result it computed from 2019 to 2025. Okay, it's computed. Just click on here. If you check from the features, it show that all of, just click on here and check the properties. We find out that you can see 2019 March Okay, 03 mainly March. We find out the average this value. Just click on here, you can get another. Suppose you can see this is the 2020 August, this value. Unit is the mole per meter square. Okay, mole per meter square. If you check this one, it show 2021-09 this, and you can see I get the same format which I mentioned in here. Okay, year and month. It show the year and month. Okay, we can get all of format. So this is my data set. Okay, so this is the way we can simply create our data set. Okay, first of all, I can get suppose this type of data, but further I simply compute each month average, every month average I simply compute, and then I can get this type of data. So further this data I can use and compute the time series chart, as well as also make the trend analysis. So a lot of things I can easily do in here. So we can get, so it's so the monthly average concentration of nitrogen dioxide in Dhaka city from 2019 to 2025. We can get all of that in here. So this is the data set we simply find out. So this data I want to use and make the time series chart. So now let's see how we can easily make the time series chart. We will also discuss about that. So for the time series chart, if you check, we already import some library, pandas library, matplotlib library, numpy library. So now we try to use this type of library and make the time series chart. Yeah. So just we take a variable. Suppose I put the variable name is that data or any data set. Just a minute. So I take the I put, suppose take a variable, suppose data 12. I just call my data set FC monthly because it is stored all of data. Just copy this variable and paste here and apply the dot get info function. Okay, get info function. So now run the code. Now further I try to take the new cell and call the data. So if you check, we can get this type of information. So when I put the get info, it give me some information. You can check the information. It show the, it's a type is the feature collection, column nitrogen dioxide, it's a floating number, date it's a string basically it show only for that year and month at the same time. So let's say it show the string, system index string, feature type features. You can see we can get this type of information from here. So it's a properties. You can see the properties. So these properties, if you check, these properties is stored the two information. One information for value, another information is for date. You can see that every properties, value and date. You can see all of properties. So properties, this is the value, this is the date. So now when you make the time series chart, we need to separate. Suppose from the properties, I create the one column for nitrogen dioxide concentration value, another column for date. Okay, same like as for Excel file. If you check, we simply create the column, latitude, longitude column. So same like, suppose I create the one column for date, another column is for value. Suppose January 2021, what's the value? January to February 2021, what's the value? So I create this type of column, two column. But in this case, if you check in my data, it show as a dictionary. It show the dictionary. You can see dictionary, keyword and key value, keyword and key value, keyword and key value. So this keyword and key value I need to separate and create the column, for one column for value, another column for date, for all of data. So for doing this thing, I simply write a code. I'll show you that just a minute. So for this, we simply take the new cell and I define here. Suppose I just take a variable, suppose rows. Suppose I create the rows. I simply create the rows. And in this rows, I simply separate two items. one item for nitrogen dioxide values, another item for date. So I create the two rows or two columns. So just I put the rows, no problem. So I put, suppose, put this symbol and put here the app and put here the property name. Basically these properties, just I call and it's paste here. Okay, properties. So now define here for f in data and call this features. 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 So now if I run the code and I want to print suppose rows, so you can see it create this type of things you can see. So now it create, this is the value, this is the date. Okay, but previously we can see it create with just this type of thing. So now it remove all of those, basically column or others, just remove, just take only for the features and create only, just take the features column. I put the features, just take the features. Okay, all of features, every month feature we find out in here. Okay, not only for that, we also put the another also, create the more better. So for that, in this time we create the data frame. Okay, so data frame we can create. What is the data frame? Data frame is called like this type of tabular information called as a data frame. So now I just create the data frame. Suppose one column is stored the date, another column it is stored for value. Okay, so further we create a data frame and we can create the data frame help of pandas library. So I already import the pandas library. So just I simply define the call the data frame. So I create variable name suppose df equal and call the pd. PD basically I already put the pandas as a pd. So pandas as a pd, just I call the pd and then define data frame function. So put here the data frame function, data frame. Okay, this function data frame, and I create the data frame from here, from this rows. Just I copy and paste here. So now run the code. It create look like that. If I show df, run the code, so you can see it create this type of data frame. You can see mainly we find out the column and also call the now two column we find out that. So it create this type of things. Not only for that, we can also add some other parameter which help me to more better making the chart. Okay, it's great, help me. So now from this df I want to call the date column. So put the df and put this sign and call the date column. So this is the column name, date column. I simply call. Okay, and I simply define here equal, I call the pandas pd, pandas library. From this library I call a function, this function called the to date time. So put here the to date time. So it's one kind of pandas function, to date time, and I define here the date. So df and define the date column. Okay, date column is really defined. So same way I can create for another nitrogen dioxide. So just I call the df. Okay, then put this symbol and put here the column name. Column name basically NO2 for nitrogen dioxide, just I call NO2. Then apply here equal, and for this I call the pandas library PD and apply the two numeric. So it's a numeric, so put at the two numeric function, numeric function, two numeric, okay, two numeric, and it's come from df. Again I put the df and define the NO2 and apply this argument errors equal chorus. Okay, this syntax we simply apply in here, as well as we also remove all of null value if there are any null value. Suppose some month there is no value, so this type of null value is simply remove. Just I call the df equal df dot drop null function, so drop drop null function to remove all of those. And we also put the short values, so we create the sorting values by date, so put it the, we just date wise we simply sorting this value, so date wise. So now just run the code, there is no problem. So now check the final output, we find out this type of output, you can say find out. Okay, so we can get the final df, okay, after creating this type of thing. So it create date, create NO2, and we find out this type of date and this type of value for each month average. Basically each month average we find out this type of value. So now we can easily use this data and make the times 3 chart. Okay. As well as you also make the trend line also. Suppose I want to make the trend analysis. What's the trend of this time? Suppose this data I want to use and make the trend also. So further we also need the slope and intercept value y equal to mx plus c. This value also need, as well as we also need to compute the intercept value and also create the slope value trend we need to compute. So for that I simply call a variable, suppose x equal, I just call the numpy np. I already import the numpy function np. I apply the arrange function arrange and call len df. So I call my data set df. So now if I run the code, if you check what happened, it create module numpy has no attribute. Okay, so it's a 1R, not double R. So now let's check. And now it's work. So now if I check the x value, what happened? It will check. So you can see it create this type of, okay, total all of the 65. Okay, well, total 65 data, basically date and value, total 65. So I create this type of arrays x and also y. So I create suppose another variable y equal, I just call the df and call the column name. Column name basically I simply call column name nitrogen dioxide, NO2 nitrogen dioxide, and from here I just take only for the value, only for the value. So put here the value or values function. So now run the code, there is no problem. If I print the y, just print the y and run the code, we find out only for the value. You can see it just show only for the value. Okay, so I can get this is the value and it show this is the index number, only index number. Basically again total 65 data, so it total 65 data, and this is the values, nitrogen dioxide values. So these things why I need, because now I compute the slope value and intercept value, and using the slope and intercept I compute the trend. Okay, so this is the main target. So further I simply do this type of x and y, and now I just call a variable, suppose slope, and also call the intercept. I call the numpy array. This is the numpy already import as the np. In the np, we find out a function. It's called the polyfit. So I apply the polyfit function between x and y, and also put here that one. So this is the formula about the polyfit function. Just I run the code. There is no problem. And if I just check the slope value and run the code, this is a slope value. And if I call the intercept, this is the intercept value, y equal to mx plus c. This type of equation we generate. And now how I can compute the trend? So just take a variable, suppose trend equal slope. This slope, it's multiply with x. Okay, and plus with intercept value. Okay, so now run the code. So let's compute the trend. Okay, and now I compute the annual slope. For the annual slope, it's very easy. Just I call, suppose, annual slope equal, just call the slope and multiply with 12 value. Annual slope is simply put the 12. So now run the code, and if you just print, suppose, annual slope and run it, so we can get this annual slope we find out for this time. We can also add some notation. Suppose we simply right here, it's a, I simply print, suppose, it's a Dhaka annual NO2 trend. I just call this variable annual slope, and I take only for the 2 decimal value after 2 digit after decimal to put at the point 2e. And you can also mention the unit. So unit we simply put here, suppose unit is, we can define, suppose, mole per meter square per year annually. So now run the code. Yeah, I think it look more better. So you can see Dhaka annual NO2 trend. So this is the negative 1.25 mole per meter square per year. We find out this type of value. Okay, so now we try to identify, suppose, that why it show the negative value. It will show positive. Okay, because we find out the positive trend, but now it show the negative trend. I think some mistake for the calculation or not, because for the day by day it increase the value. Okay, it increase the emission, but it show the positive negative trend. Okay, let me check the formula again. So we simply call the slope. Okay, so we simply define np trend and we find out this type of things. And depth, it just come from NO2 values. It is an NO2 values. Then we call the slope and intercept, call the numpy function polyfit. Okay, and compute the slope, compute the intercept. And define the trend equal slope multiply with x plus intercept. And annual slope from the slope multiply with 12 for annual. Okay. So it will be positive value, but it shows a negative value. I don't know. I think some problem or not. Okay, let me check. Okay, I make the chart and further also try to check it and find out the better solution for that. No problem. So let me try to put the chart and check the result. So for the chart, I already imported a library. It's called the matplotlib library. So just I simply call the plt from the matplotlib. So plt dot, I define the figure size, figure, and then define fig size, well, I put suppose 12, 5. Okay, this is my figure check, like fig size I put in here. So now we just simply create some plot. So just call the plt dot plot and define depth. I just create the plot for first time for date. I define the date. Okay, date. Then put at the comma sign. Put at the y. Okay. And now also define suppose line width. So I put the line width. I put suppose 1.5 pixel. Level title. I put the level equal define the monthly mean NO2. Okay, you can put in this type of level. So now if I just run the code, okay, we can get this type of chart. You can see, but it just show the monthly average for every year. This chart we also create more better. So let me try to add some other option. So this is the one we find out that, as well as I also add suppose trend line, because we already create the annual trend. So this annual trend, I want to add the trend line chart. Okay, then we can easily get the idea it increasing or decreasing, what happened for this class. Okay, so for that we simply create the another plot. So put here the plt dot plot and call the depth. Sorry, depth. So same, just I put for date. It's my x column. Okay, and for the I also add suppose trend. So put here the comma sign and put here the trend. Okay, trend, and also put suppose line width. Line. I'll put line width suppose 2 pixel and define define the level. Suppose put at the level level equal, define the level, simply define suppose this value f, or is right, suppose f, we print something in here. I print, suppose it's a print the bracket and put the second bracket and call this annual slope. This thing I also add, mainly this value I also add in my chart also, just I call it paste here. Okay, and also define the unit, mole per meter square per year, and paste here. Okay, so now on the potential, what happened? Okay, you find out this type of trend, you can see. You find out this type of trend look like that. Yeah, so this is the way to add the trend. So it looks more pretty when I add the title, all of those. So let me try to add suppose title on the chart. Suppose I want to add the title, suppose X level title I want to add and Y level title. So PLT dot X level, and for the X level I put here, suppose it's a year. So now run the code, it shows the year. If you check year, suppose I put the Y level, so PLT dot Y level, I put the Y level, title is, suppose I put it's a NO2, nitrogen dioxide, mole per meter square. Just run the code. So it also added, you can see nitrogen dioxide mole per meter. We'll also get this type of title. Not only for that, I also add the chart title also easily, chart title. So for that, just put here the plt dot title. So as you put here, suppose plt dot title. So plt dot title, just define your title again. So I put here, I put the title, suppose Dhaka city, Dhaka city, suppose monthly NO2 time series chart 2000, 2019 to 2025 or 24 or 25, any title report. So this is our chart title. It'll say add look like that. So if I run the code, it also added. Okay, you can see the title. Not only for that, we also add the legend. So you can see there is no legend in the chart. So we'll add the legend. So for the legend, just same way, plt dot legend. Just I use it and run the code. So now legend is also added. You can see monthly mean NO2, and it shows the trend. So this is the trend chart. This is the monthly mean NO2 chart. Only this line and this line. Okay, what represent? We also get it from here. As well as I also add suppose grid. You can see there is no grid. I want to add the grid. So for the grid, just put here the plt dot grid. Just run the code. Put the true function, true. Okay. Then run the code. So now it also added the grid. You can see it creates some grid. This type of grid. Great. So grid is also look more better for that. Not only for that, we also put here the type layout. We also create the type layout. So plt dot type layout. and run the code. So it create the tight layout, look more pretty. Okay, tight layout we can also add. And finally, we are just after all, we can say pld.show function. So now run the code. So now it create look like this chart, and the chart we can also save as a PNG file format. Easily you can save it. So you can also just click on here, it will be saved. Or if you want, I think it's also better, we can also download this chart with high resolution. Okay, when you just simply just click and download or save the file, it's not the high resolution. Okay, this chart you cannot use in your paper. So it's also better, we can directly import without a screenshot, without save. Okay, we simply download this file, we download this image file as a PNG format or PDF format, which is more better, okay, for our map. So let me show you that how to save it as a file, well, PNG file or PDF file format. Okay, and also get the high resolution imagery. Okay, for importing this type of file. So for that, we simply use FIG. I take a variable fig. Another variable I take, suppose AX equal. I just call PLT. I already import the PLT. PLT dot subplots and define the fig size again equal. How will I define? It's a 12 and 5. There is no problem. So it create, you can see this type of figures size 12 and 5. So I add some necessary option. Suppose here I add ax dot plot plot. I want to create the plot for two information. One information for date. So I call my data frame df. From the data frame, I just call my column name. Which column I want to use for make the chart. So I want to use the column from date. This is my one column, and call the another column df. Another column it's just no2 column. Okay, just I put here no2. Okay, two column I want to use and make the chart. I put here no2. You can also define, suppose, line width or line width. Sorry, it's a lowercase. Line width we also put suppose 1.5, and also define the level. So level equal, I put the same level. I put the level, suppose it's a monthly no2, monthly mean in no2. So now on the code we create, if you check, it create this type of chart. I want to add the, suppose also add trend line. So same, just put the same, just I copy the same line of code and paste here. So ax.plot df dot date. So now I create the chart for trend. So just I remove it and apply the trend. Again, it's a lowercase trend. And line width we can also define, suppose 2 or anything. Okay, then it also include the, I put suppose 2. And we also add the level. So I add the same level. I say already added in here. You can see the level. Just I copy. define the level. So now run the code. Oh, sorry. Mistake in here. This quotation and in here. Okay. So now you also get this type of print, as well as we simply add x dot set x level. So I define, suppose x level is here. Put the font size. Font size suppose 12. Yeah, so we simply add it. So same, we also just put another one. X set y level. I put it say NO2 mole per meter square. And font size I put suppose 13. Okay. Simply define, as well as we also put here title. So same, ax dot set title. I just copy the same line of code for the title. And then run the code. It also define the font size also. Suppose I just increase the font size of the title. Put the comma and put the font size. Suppose I put it's a 15. Okay, so now run the code. I create this type of chart. Okay, so now you can see what is the difference between the two things. So this type of PLD function I can also use, but further I cannot increase the title font size or others. It's not possible. But now you can see, you can also increase the title font size. We can also decrease or increase this type of things. So this is the fig and ax, two variable I simply take, and then I simply set this type of things. Not only for that, we also add the leaves and others, then it will look more pretty. And finally, we can also export as a PNG file format or PDF file format. Okay. So I put at the ax dot legend. I also add legend. Another code. So now I hope it also added the legend. And then I also add suppose grid. So ax dot grid. I also add the grid. Just put the true. So it also add the grid. And also create the type layout. So put here the fig dot type layout. Yeah. And now finally just run the code. So now I create this type of chart. So now the chart, how I can export as a PNG file format with high resolution. So for that, we simply apply fig dot save fig function. Okay, save fig function, and we define, first of all, we simply define the file name. Suppose I put the file name is chart. You can put any name. I put this type of name. Okay? And further comma sign and put here DPI, which is very important. I put the 300. Okay, it's mainly define the resolution. So up to 300, it's look more pretty, and it also accepted different types of journal. So I put DPI 300, and also put the another argument which is BB box insists equal. I put the type. And finally, when I run the code, so now the chart I hope you can see it's loading. So now it also saved. Okay. So now where is it saved? So we already know about that. We already create a project folder, air quality. Okay. So if I just go this folder, I can easily get the chart. Okay. So not only for the chart, anything when you work, suppose you export a raster file, you export anything, this file automatically saved under the air quality folder. So now let me check it will be stored or not in the under the air quality folder. So just I open this folder G. I put the name air quality. Just I open. So you can see this is my file which I exported as a PNG file format. So this is a final output. We simply export this chart with high resolution. So now the chart I can easily add any kinds of research paper or any kinds of presentation I can easily add. Okay, so you can see it look more pretty, and this image quality is also high. But when you take the screenshot or when you take the photo, then it look create some problem. So now you can see you can get this type of chart look like that. Okay, it look more pretty. Okay, anyone in question you can ask me please. And this code when I send you, so in this time I just show you the example for one data set, but almost all of data in Google Earth Engine when you work using the same code you can also use, and you can just simply need to modify. Okay, otherwise everything will be same. Okay, for the full code when you work. So after the class I will send you this code. So this code you are not only use for air quality data set, not only for that. So you can also try to use this data. You can also try to use this code for different data set. Okay, NDVI data set or MODIS NDWI, MODIS LST are also useful for other data set. Okay, you try to explore this type of code. You also try to adapt for other data sets. So it's also good practice also for you, because when you practice you face some problem, then you also discuss about this type of problem. Okay, so now you also try to use other data. Suppose if you check the, we just work only for the nitrogen dioxide, but you can also do for the same way for other data, suppose sulfur dioxide or ozone or also formaldehyde or carbon monoxide or aerosol index. So this type of data you also try. Okay, also check the result, methane or sulfur dioxide. So now how I can visualize the map. Okay, so in this time we just talk only for the time series. Okay, so now how I can add the map, okay, to check the distribution of nitrogen dioxide for different area, where is the high, where is the low. So this type of things I try to explore. Before that, anyone any question you can ask me please. Any question? Yeah, I hope there is no question, so let's continue. Yeah, so how I can display the map, we will also discuss about that. For displaying this map, first of all, you need to compute. Suppose I want to compute 2019 to 2025 all of data. I create suppose average and make the one map, as well as I can also display suppose every month average map. Okay, so first of all I discuss about that, how to show you that suppose 2000 full map, how to display. So for that we simply just take a variable, suppose no2 mean equal, I just call my data, mainly image collection. If you check the image collection, I already have the image collection NO2. Just I call this variable name and paste here. Suppose I need the data. Suppose 1 year or 2 year or which year you need. You simply define. Suppose I put here the filter date and define suppose time, mainly your time started and ended. I put the time. Suppose I need the data in year of 2024 1st January from 2024 suppose December 31. So this is my time period. I need the data. And 1 year data I need. Suppose you need another year, simply change the time. Suppose you need that as 2000, 2001, or just put the time. I need suppose average data. Okay, average data. I put the mean, and further I clip with my study area. So just use the clip function dot clip with ROI. So now I simply define here the parenthesis and also close this parenthesis. Okay, now run the code, there is no problem. So now this is the NO2 mean. We find out the yearly. Okay, so you can take the 2 year, 3 year, 4 year, 5 years, whatever you can put. So when you work with for the monthly, so how I can get the data? Just I copy the same line of code. I put suppose variable name is the NO2 month. So as I need the data year of 2000 month of January. So I put here the 1st January. So I can get the result 2024 only for January. I create the average. So now run the code. So now I can get the two types of data. One data for yearly, another data for monthly, only for the month of January. So I need them February. So just put here the change the month or months, simply change the month, then it will be work. Okay, you need suppose seasonal, just simply put the season. Okay, or any year, just simply change it, then it will be work. So now how I can visualize the map? So for that we simply call, we need a visualization parameter. So we simply create suppose NO2 EIS visualization and make a dictionary. So I define here mean value. Mean. I define the mean value suppose 0.0000 or 0.024. You also change it after some time, then it will look more. Suppose I put the 1 value. After some time, we also change it. Just stress the data, we also change it. And max I put here, suppose max. I put the max value 0.000345. This type of value simply put in here. And also put the another one, it's called the plated. We define the color plated. Just make a list of color plated. So I define the color plated. So suppose I put the color plated low, it show the black color. Greater than it show as a blue color. Then it shows suppose another color simply given in here as a purple color. I define suppose as a this color, cyan color. So different types color, cyan color. I want to add suppose another color, green color. Suppose I put here that another color is yellow color. So then I put here suppose yellow, then put in the orange, and finally high, it shows as a red color. Okay, it's a high density I want to display. But now if you check, if I run the code, there is no problem. Now I need to add a map. Okay, when I add a map, and this map, if you check, it also already have the map, this type of map in the ArcGIS Pro. But now I want to add the map in here. Okay, so this map, it's come from the GEmap package, GEmap Python package. So just I take a variable, suppose map, and call GEmap dot map. Okay. So if you want, you also put here the center. I put the center, mainly put the latitude and longitude. I put suppose 23 point or 23 latitude and 90 longitude. I put in here, and also define the zoom level equal suppose 10. So I create a variable, and now in this variable, if I just run the code, it added the map layout. Okay, it create this type of map layout. Okay, and I want to add the layer. So how I can add the layer? If you check, just put here map dot add layer, and call this. I want to add suppose average, yearly average. Just a call and paste here, and put the visualization parameter, and call the layer name. So layer name, I just put the layer name suppose annual NO2. So in this time, if you can check, in the left side there is no layer. Okay, that's only two layer. But when I run the code, this layer automatically added in my left side. If I run the code, you can check, just run the code. So you can see it's added. Yeah, so you can see it added the another layer, and this layer name is the annual NO2. So it's automatically added, okay, in my map layer. So now where is the map? Okay, let me check it. Just zoom. Loading. If you check in here also, just go to your place, and this map is also loaded in this map. Mainly ArcGIS Pro map is also loaded for this map, and also loaded in here. So it's just mainly connecting with the Google Earth Engine server and load the data in my map. It's working. It's loading again. It's loading, but takes some time. And again, also loading in say one map, also loading in here. Okay, just let me zoom. I think we need to stressing the data, then it looks more pretty. We find out the better visualization. because it's loaded. Okay, but you can see it look this type of black color because we also need to change the visualization parameter. So let me change it, the visualization. If I just click on the setting button, if you check, or just click on the layers button, so from the layer just click on here. So it's still loading, and further from here just you can see the stress level. Stress level, if you check stressing, I just put 98% stressing. So you can see loading the range, minimum and maximum range. So just we simply copy and paste in our code. So just I use it. So just I copy the minimum range, just copy and change it. Just change it. And also copy the maximum range and change it. Okay, so now I run the cell again. Just I run it, and before running that I still remove my previous layer. Just I remove this layer. Okay, when I run the code again, you can see when I run the code again, when I sell the code, it's added the new layer again. Just click the run. So now you can see it just loaded the another layer, new layer also added. So now we try to check the visualization again, because in this time we simply apply the stressing. It's loading. It's loading.